A student wants to find the concentration of hydrogen peroxide in a solution of hydrogen peroxide, aqueous. The student can use one of two titrants, the dichromate ion, Cr2O7, or the cobalt ion, CO2+. The balanced equations for the two titration reactions and the half reactions and E0 values for the systems related to the titrations are given on the next slide. Here's dichromate as titrant, here's cobalt as a titrant, and here's our half reactions and E0 values. So please look at these for a bit and then move on to the next slide. Part A, Part 1 of Part A. Determine E0 for the reaction between the chromate ion and hydrogen peroxide at 298 K. Part 2, determine E0 for the reaction between the cobalt ion and hydrogen peroxide at 298 K. B, based on the calculated values of E0, the student must choose the titrant for which the titration reaction is thermodynamically favorable at 298 K. Which titrant should the student use? Explain your reasoning. Then Part 2, calculate the value of delta G0 for the reaction between the chosen titrant and hydrogen peroxide. Calculate E0 for the reaction between the chromate ion and hydrogen peroxide. E0 is going to be the substance that is reduced minus the substance that is oxidized. So let's go down here and look. What's the valence of chromium there? Well, oxygen is -2 for each one. -2 times 7, -14. The overall ion is -12. So that means chromium has to be what? +12 for the two of them, so +6. So chromium goes from +6 to +3. It is being reduced. So this will be our first E0 minus the second one. So it's 1.33 minus 0.70 equals 0.63 volts. Now let's look at cobalt. In this case, this is what's going on. Cobalt 2+ is turning into cobalt 3. So that's being oxidized. All right. So in that case, the 1.84 comes second. We have the 1.77 minus 1.84, and we get minus 0.07 volts. Based on the calculated values of E0, the student must choose the titrant for which the titration reaction is thermodynamically favorable at 298 K. Which titrant should the student use? Explain your reasoning. The student should use the dichromate ion because the value of E0 is positive, which means that delta G is negative. Remember, they're opposite in sign, and the reaction is thermodynamically favorable. Now calculate delta G. Well, we have delta G is minus NFA, and here are the moles of electrons. Here's the Faraday constant. Here is 0.63 joules per coulomb, and then we have to convert that to kilojoules. So we get delta G is minus 360 kilojoules per mole.